Why is it? There we go. I'm focused. Okay. So we're going to look at 2025 AB and BC. I need to fix this heading. This is a common question. And these questions were just dropped a few minutes ago. I have not read this question, so you're going to get to watch me solve this in real time and process it without having a rehearsed, polished solution. I very likely will make mistakes, so if you see mistakes, comment them below. I will answer to any questions like that. And if you like this, go ahead and hit that like button. Yay! Okay, so table problem. Student starts reading a book at time 0 and continues reading for 10 minutes. The rate at which a student reads is, man, this guy's warming up. Anyway, it's given by a differentiable function, R. Okay, approximate R prime of 1, show the work, and indicate unit. Okay, this will be a nice one. So A, and again, this is a did I say at the beginning? This is a non-calculator question. So question A, we are approximating R prime of 1, and recently they have decided to tell you exactly how to do that, and that is by using the average rate of change from 0 to 2. So that would be R of 2 minus R of 0 over 2 minus 0, or you can jump straight to 100 minus 90 over 2 minus 0. And in these problems, they really want to see the difference quotient. So even though 2 minus 0 is very clearly 0, and 2, they may give it to you if you just write 2, but I very strongly encourage my students to literally write a quotient of 2 differences, hence the name difference quotient. Now this one's pretty easy to clean up. That's 10 divided by 2, which is 5. However, as soon as you have all numbers, I think you should stop. So I'm going to draw lines through those just in case I made a little careless mistake. Show the work leads to your answer and indicate units of measure. So in the numerator, we subtracted words per minute. So the units would be words per minute in the numerator. And in the denominator, we subtracted minutes. So the units would be words per minute, or you can write that as words per minute squared. Must there be a value R such that R of C is equal to 155? This one's going to be an intermediate value theorem. And when you are citing the intermediate value theorem, you need to establish that your function is indeed continuous. They do not tell you that the function R is continuous. They tell you the function R is differentiable. So I must say that R of T, R of, I don't want that italicized. There we go. R of T is differentiable. Therefore, R of T is continuous. All right, so I make that declaration, and then I am looking for 2 values of R, one that is above, what am I looking for, 155, and one that is below 155. And I like to keep it simple. If they suggest using an interval 0 to 10, I like to use that given interval. R of 0 is equal to 90. That is less than 155. R of 10 is equal to 162. That is greater than 155. Therefore, that would probably be sufficient. That would probably be sufficient in AP readers, but to an AP reader. But I'm going to give a conclusive statement. Therefore, R of, I'm really having a hard time here. R of C equals 155 for some X. Is it X or T? T equals C, and that'll be 0, 0, less than C, less than 10. You don't really need that last statement, but it looks pretty, doesn't it? Use a trapezoidal sum with 3 approximations to approximate the value of that. Okay, that's pretty nice. So let's look at this one, number C. So the trapezoidal sum, you don't have to write the integral that this trapezoidal sum represents, but I like to. So the integral from 0 to 10 of R of T dt, and this is an approximation, so we need to put an approximation symbol. And the first trapezoid is half of, and the heights of the trapezoid are your delta t's, so 0 to 2, that is a delta t of 2. The bases of the trapezoid are the function values, so on that interval it's 90 plus 100. And then I go to my next trapezoid, that's going to be half of, and 2 to 8 is a distance of 6, and the function values are 100 and 150. And then my last trapezoid from 8 to 10 is a delta t of 2, so the height of the trapezoid is 2, and the bases have lengths of 150 and 162. Use the trapezoidal sum to approximate the value of, show the work that leads to your answer. There's no interpretation. That doesn't say include units. We're done. We're done. I would not waste my time cleaning that up. Now, that said, I'm about to waste my time cleaning this up. So that's 190 plus 3 times 50 is 150 plus 312. So that's 340 plus 312 is 652. But I'm going to cross the line. I'm going to cross that out just in case I'm wrong. Now, I did that very quickly. The answer is acceptable in this format. You also can write the sum of the bases. So you say half of 2 times 190, half of 6 times 250. But I like to leave it like this. Number D. A teacher also starts reading at time 0 for the next 10 minutes. The rate which teacher reads is given by that function. Based on this model, how many words has the teacher read in 10 minutes? Okay, so W of T is in units of, let me double check this, words per minute. We want the actual number of words. So we need to compute the definite integral from 0 to 10 of that function W of T. Typically, I would write W of T, but since this is a non-calculated question and I have to compute this antiderivative on my own, I'm going to write the expression. So negative 3/10 of t squared plus 8t plus 100 dt. And we'll work this out. This is a fairly nice antiderivative. That will be negative 3/10 of t cubed over 3. Those 3's will divide away. Plus, that will be 4t squared for the antiderivative of 8t plus 100t. And then I will evaluate this guy from t equals 0 to t equals 10. And that's going to give me, I'm going to go ahead and divide these 3's out. Those will cancel. So that will be negative 10 cubed. I'm going to write it like this. Negative 10 cubed over 10. That's cubed. Plus 4 times 10 squared plus 100 times 10. And then when you plug in 0, that will return all zeros. And that is an acceptable final answer. If you want the simplified version, that's negative 100 plus 400 plus 1,000, which would be 1,300. But we don't need to clean up, so I'm going to cross that out. I believe that's right. And I think I'm done with question number 3. That one wasn't too bad. Not too bad. Manageable problem. I like it. If there are any mistakes, let me know. And I am off to do number 4.